In this video, I'm going to do a worked example of simulating the selection sort algorithm on an input. So let's take a look at this problem prompt. Over here I have my inputs. And I want to show a trace of execution for this algorithm. Trace should include the initial state of the array followed by the array state after each swap is made. So I'll start by doing this. So I'll do 7, 23, 25, 13, 2, 12, 3, 16, 43. All right, so those are going to be my values. And what I want to do is I want to simulate running this algorithm. Well, the way the algorithm works is by sorting one position at a time. So this right is basically going to be my I over here. This is my ith value over there. Initially its I is going to be equal to 7. Well, I is going to be equal to 0, which is pointing at the number 7. That's the first thing in my array. All right. So yeah, let's simulate our algorithm. Our algorithm, what our algorithm wants to do is basically find what is the element that goes there. So in this case, I'm going to look through the list and try to find what is the smallest thing. In this case, 7, 25, 23, 25, 13, 2, 12, 3, 16. I would find that my 2 is the smallest one. So this is the smallest. And that's what I end up wanting to swap forward. So let's draw this over here. So 2 basically gets swapped forward to where that 7 is. So initially I is 0. So that means we want to swap to that first slot. So over here, basically I start to draw in here as I have my 2 over here, place at 7, and then everything else stays the same. 23, 25, 15. Now my 7, which I was basically swapping, is now appears there. 3, 16, 43. Okay, and I'll have some additional notation over here. So this is now this over here. Initially it was I equals 0, which meant the 7. Now we're going to go to I equal 1. And over here, right, we basically said that our smallest one, small, was that 2. So yeah, we basically have done a little bit of work. So now if I look at my data, right, I have basically this sorted region and this unsorted region. So I need to repeat this again, right? So I equals 1. I'm going to go and find, what is the smallest thing in this array from position 1 and going forward. So 23, 25, 15, 7, 12, 3, 16, 4. Well, it looks like in there 3 is going to be the smallest one. So 3 is going to be, again, the smallest. So 3 is the smallest, so I'll have to move that forward. Get swapped with 23, right? 23 is the thing that was at index I equal 1. So my next line. And 12, and then my 23 gets moved forward. That stuff stays the same. All right. Another iteration, I equals 2. So in this case where I want to fill in, this is now my sorted, and this is my unsorted. So over here, right, I'm going to go from position 2, look forward, what is the smallest thing. Here, looks like the smallest thing is going to be our value 7. So in this case, right, I'll go back to drawing. So 2, 3, 7, 15, 25, 12, 23, 16, 43. Right, so again, this is unsorted, sorted. I equal 3. All right, got to fill in my third slot. So let's see, 2, 3, 7, those all stay the same. Let's see, this is my 15 is what I want to update, so what I want to replace. So let's look in there. What's the next smallest thing? 15, 25, 12. It looks like 12 is going to be my next smallest one, so that one I'll basically swap forward. So that gets swapped forward. Stay the same. My 15 gets moved over here. 23, 16, 43. All right, and so I have my sorted region in front, unsorted region in the back. Can maybe do this one more time. We'll do I equal 4. So now that 25, that's the position I want to update. So in this case, look for the smallest one, going to be 15. So this front part stays the same. And over here, right, this 15 gets moved up. Basically just swap that 25. Other stuff stays the same. So again, sorted region, unsorted region. Sorted region is constantly growing. So in here, right, I would need to do this a few more times. So I've done this 4 times, but I need to do it basically 3 more. So I should also have in here, I don't really have space, so I won't work through it. But I would have an I equal 5, I equal 6, I equal 7. Because I need to still basically find out, what belongs in that space there, what belongs in that space there, what belongs in that space there. Usually the last one is a kind of a freebie because it's like, well, I don't have any choices. The smallest thing in a list of, the smallest element in the subset of an array of one element has to be that one element because there's nothing else that could be smaller than it, right? So that's just the one thing. So yeah. This is a trace of the array. If you were doing something like this, like on an exercise or something, you would need to show this, basically each of these steps. So they are basically going to be, here in this case I have, let's see, there's 9 elements in there. So 9 elements implies you're going to run your algorithm 8 times. Because the last one right is a freebie. So yeah. All right, so there you go. That's a trace of the selection sort algorithm.